Question 6. We're asked to calculate the mean and standard deviations of the times that Jack was waiting before he spoke to an internet advisor. So let's do the mean first. So the mean is x bar, which is sigma x over n. So what is sigma x? Well, sigma x is the sum of these things. So that would be, so if we type that into our calculator, we get, you'll be able to hear my tapping just now, we get 78. 78, and how many do we have? 1, 2, 3, 6. So yes, 6 goes into 78 13 times. So then our mean is 13. So now that we've got the mean, we need to calculate the standard deviation. So to do this, we need to know what x minus x bar squared is. Hence, we have this table. So how you would do this is you write your x value. So what is your x value? It's just, they're taken from here. Look, each one is one of those. Then we have our x bar, which we know is 13. So then we calculate x minus x bar. So in this case, 13 minus 13 is 0. And then we square this and put it in there. So you just go through all of these for all your x's, all your n's up here, doing that. So 12 minus 13 is -1, -1 squared is 1. 22 minus 13 is 9, 9 squared is 81, etc, etc. Then, in the final column here, so then you add all of these up, and then this figure here is sigma x minus x bar squared, which is what we need, because if we take one of the versions of our standard deviation formula, then we know that S, so standard deviation, is equal to the square root of sigma x minus x bar squared over n minus 1. So we can just substitute this value right into here. So x equals square root, what's our sigma x minus x bar squared? Well, 164. Our n, minus 1, so n is 6, because we have 6, minus 1 is 5. So typing that into my calculator, I get 5.727128425. And then, so we're going to round that to the most, probably one decimal place, because that seems the most reasonable, which would be 5.7 minutes. Because our units that we're using is minutes, because these are times. So then we need to make, in part B, 2 valid comments comparing Sophie's data to Jack's. So we know that Jack's mean waiting time was 13 minutes, so Sophie's is 15. Therefore, Sophie on average waited longer. So we can just write that. Since 13 is greater than 15, on average, Sophie waited longer than Jack. And then what was her standard deviation? Well, her standard deviation was 4.3 minutes and Jack's was 5.7. So the greater the standard deviation, the less consistent, or you could say more variable. So we could say, since 4.3 is less than 5.7, Sophie's waiting times were more consistent. So I think those two are acceptable answers, but please consult a maths teacher because there are multiple ways to phrase this, and I'm not a maths teacher, so I'm just somebody who makes maths videos on the internet. Thanks for watching, everyone.